Hey guys, today we're going to be talking about hypertonic, hypotonic, and isotonic solutions. First off, we need to look at the structure and function of a cell membrane. A cell membrane is a semi-permeable membrane, which means it's very selective in which molecules are allowed to pass into and out of the cell. Let's look at a big salt molecule trying to enter the membrane. It's so massive that it won't fit through the aquaporin protein channels that are embedded in the phospholipid bilayer here. Therefore, they require special channels that allow them to move freely in and out. So let's erase that. And now let's look at a water molecule. Water molecules are just the right size to pass through the membrane with ease without using energy. So if we have this water molecule here, it can go from the outside to the inside of the cell. A key concept when talking about tonicity and water potential is concentration. So concentration is a measure of how much solute is present per volume of solvent. Here we're looking at the cell's environment. So an example would be a more watery versus a more salty environment. When there are more solutes present in one area versus another, a process called diffusion occurs. And this is the movement of particles from higher to lower concentrations. So if we have all these solutes here, they're going to want to move through the membrane to an area of lower concentration. These molecules don't want to be crammed together, so they're going to try to find a space where they're less bombarded by the molecules around them. Think of being stuck in a house with all of your family members, as we all are in quarantine right now. You don't want to be crowded in one room, so you move to different parts of the house to get some space from each other. The same thing is happening here. The molecules diffuse from areas of higher concentration to areas of lower concentration. In doing so, they achieve dynamic equilibrium, where there is an equal amount of molecules on each side. So there is an equal amount of solutes here and an equal amount of solutes here. Now that you understand the role of concentrations and diffusion, let's look at three types of solutions. We have a hypertonic, hypotonic, and isotonic solution. In a hypertonic solution, there are more solutes on the outside than on the inside of the cell. So, our little orange molecules representing our solutes, and these are going to be our water molecules. So, I'm going to dictate the direction that the water is moving with these purple arrows. The water will want to move out of the cell because there are less solutes in its way, blocking it from moving outwards. As you can see, there are less solutes inside of the cell versus outside of the cell. Overall, the net movement of water will be out of the cell. And as you can see, it's just easier for water to move out of the cell because less things are blocking it. Things as in solutes. So when this occurs, the cell shrinks and undergoes a process called plasmolysis. It's when the cell contracts, loses a bunch of water, and shrinks. So at the end, a cell would probably end up looking something like that. Basically, all of the water is moving out of the cell, so the cell shrinks. In a hypotonic solution, there are more solutes inside the cell than outside of the cell. Water molecules move into the cell because there aren't as many solutes blocking its path. This causes the cell to swell and sometimes even burst due to the influx of water molecules, and this process would be called cytolysis. In an isotonic solution, the concentration of solutes are equal. This means that water flows in an equal amount inside and outside of the cell. There is zero net flow of water, so it just means that these solutes here on the outside equal the amount of solutes on the inside.